Hello everyone, I Naimullah. So today I am going to solve a problem on Venturimeter, that is from third module fluid dynamics. So for the last class, as we discussed a derivation, a theoretical concepts on Venturimeter. So today I am going to solve a problematic concepts on Venturimeter. So here we have taken a problem. This problem, they in video examination they have asked for 6 marks in June 2016. So here, for solving the problem, we can write first of all the given data as of a venturimeter of size 200 mm and 100 mm is used to measure the flow of liquid of specific gravity 0.85. So a venturimeter of size they have given for the inlet pipe diameter. So we have drawn a basic roughly diameter. So here the inlet size d1, inlet pipe diameter d1, and here the throat and the outlet. So inlet for the converging and for the throat, and for the outlet it is diverging. So here the inlet, the size they have given 200 mm. So we have taken for the d1 200 mm, that we have converted in meter, so 0.2 meter. For the throat section d2 they have given 100 mm, that we have converted that one into a 0.1 meter. So we need to convert all the dimensions are in meter. So here then we find out the area 1 for the inlet section, area pi by 4 into the pipes, it is in circular, so the diameter d1 square, that is 0.2 square. So after calculating that one, we got an answer, that is for area, that is 0.031 0.03141 meter square. This is in diameter meter, so the square meter square for that. And A2 area 2 for the throat, same, we can calculate pi by 4 into d2 square, that is, so we got, after calculating this one, we got an answer, that is 0.00785 meter square. Okay, next what they have given, specific gravity. So the specific gravity, that is for yes, that is 0.85 they have given. If the mercury differential manometer head, they have given differential manometer head, that is x 250 mm, that we need to convert it into meter, that is 0.25 meter. Okay, next what they have mentioned, what they have given, find the discharge. So they asked to find out the discharge, that is q. Okay, and also find the absolute pressure at the throat. If the pressure at the inlet is, inlet pressure they have given, that is p1 pressure, inlet pressure p1 they have given, so 49 kilopascal, that we need to convert it into pascal, 49 into 10 raised to 3 pascal. Okay, even they have given, again they have told to calculate, also find the absolute pressure at the throat. Absolute pressure they have told to find out the absolute pressure, that is for p2 P2 we need to calculate. For this, first of all, we go for solution for the we don't know the pressure head. So we don't know the pressure head. First of all, we need to calculate the pressure head of Venturimeter. Pressure head, or you can told it is an head loss, that is for small h. X I have given differential manometer head into specific gravity of mercury divided by specific gravity of liquid -1. Okay, here x 0.25 and 13.6 specific gravity of mercury. It is a standard value for the liquid. What they have mentioned here, for the specific gravity of liquid they have given, yes, it is 0.85 -1. So we got the value of h as 3.75 meter. Okay, 3.75 meter. Next again, so we need to calculate discharge Q. So we are having a formula from the discharge formula from the Venturimeter derivation, coefficient of discharge into area A1 into area A2 into square root 2gh the whole divided by square root A1 square minus A2 square. Okay, here we can put the values. Coefficient of discharge, that is they have given here 0.98. So we can write down 0.98 of your coefficient of discharge into A1 area 0. We calculated 0.3141 into 0.00785 into square root of 2 into g, that is gravitational constant 9.81 into h, that is we calculated 3.75, the whole divided by square root of A1 square, that is 0.03141 square minus 0.00785 square. So Q discharge we got the value 0. After calculation 0.0681 meter cube per second for the discharge, that is in meter cube per second. So this one we need to calculate it in, we can put it in liters per second cube to 10 raised to 3, can multiply the liters per second 10 raised to 3, we can multiply 68.1, we got liters per second. We got discharge value as in liters per second after multiplying this one into 10 raised to 3. So after this is the first step, got over pressure head, we calculated discharge, we calculated the discharge. Here also we have given find the discharge through the Venturimeter. Next, also find the absolute pressure at the throat. So we need to calculate the absolute pressure. For that, step 2, now again pressure head we can take H is equal to P1 inlet pressure minus P2 outlet pressure to gamma. So H we calculated 3.75 is equal to P1. They have given inlet pressure 49 in kilopascal, that is 49 into 10 raised to 3 pascal. 49 into 10 raised to 3 minus P2 we don't know, we should calculate, we should find out that one. And for gamma that is specific gravity of liquid into G, it is 0.85 into 9810. So after calculating this value, we got answer P2 as 17.7306 into 10 raised to 3 pascal. So we calculated this as a gauge pressure. What we calculated as a gauge pressure. So we got as of for the gauge pressure. Then again we can calculate. So we got the value of gauge pressure as, and again we calculate an absolute pressure. We know the value of gauge pressure, so we can calculate the value of absolute pressure. For that, P2 absolute pressure is equal to pressure, atmospheric pressure plus gauge pressure. So the atmospheric pressure is, it is a constant value 1.0132 into 10 raised to 5 plus gauge pressure, we got the value as 17.7306 into 10 raised to 3. After calculating this value, we got the value of absolute pressure is 17.73. Okay, we got the value of P2 absolute pressure as 119.05 into 10 raised to 3 pascal, that we convert it into 119.05 10 raised to 3, that is kilo pascal. This is the final answer. Okay, this is a final answer. This is asked for 6 marks in your VTU examination in June 2016. Okay, you can solve this.